Hello everyone. This video will be discussing on IGCSE Additional Mathematics Minor for year 2020. Okay, your subject code is 0606. I'll run through very quick our agenda for this video. We'll be covering preparation towards examination, syllabus content and keyword, marks and grading, examiner report. In preparation towards examination, ensure your examination slip is properly printed out. All information is correct together with the subject code. You will have an examination slip and you need to prepare get your identification card also together with you before you entering the hall. Make sure all the information including your IC number, your passport number, your full name, your subject code and your number of subject you are taking all are properly printed out in that paper. Any information mislead, please clarify with the registration officer and get it fixed before your exam. Second thing, prepare sufficient material related to the paper. For maths, we only require a stationery, which is pen, pencil, ruler and eraser. You don't need a compass or protractor. And prepare a scientific calculator as well, and make sure it's a non-programmable calculator. Get enough rest and stay healthy for at least 2 weeks. Okay, you don't want to fall sick right before your exam. You have done a lot of effort, a lot of hard work to prepare for the exam. You don't want to just on the day you fall sick. So keep yourself safe and also healthy at least for 2 weeks before your examination session. Keep your examination slip properly and identification card properly and visible. Maybe you keep in a place where before you leave your home you can see on your table or in your wallet. You don't want later you come to the exam hall and then you realize, oh, I have left this document at my home, and you get panic and then you need to ask the school or the center to print out for you. It's going to consume time and it also will affect your mood to do the exam. Okay, so make sure all these basic things you keep visible with you, or maybe you can set an alarm associated with your schedule of your examination. Like I say, set a reminder for your examination schedule and alarm. Your exam timetable will be released way earlier. You can actually check through, and then you can set an alarm on your smartphone. Maybe you can give about 1 day in early and then 2 hours before examination, so it will give you sufficient time for you to prepare, leave your home and arrive at this exam venue together with all your stationaries, calculators and your exam slip and your identification document or card. Okay, syllabus content and keyword. We have total 16 chapters in maths. I will cover all the 16 chapters. What are the chapters, all the content in the chapters, and also the keywords that associated with the chapter. So the first chapter will look in function. In function, wait, let me get my highlighter. Okay, so in function you must know these few keywords: function, domain, range. Range is actually an image set, one-to-one function, inverse function and composite function. I believe most of you know what we call that function, domain, range, Okay, I want to highlight a little bit on this inverse function part. Okay, so why I want to highlight about one-to-one and inverse function part, we all know they'll give you a function, okay, then they'll ask you to find the inverse, then they'll ask you whether this function has an inverse or not. So for a function to have inverse, it must be one-to-one relationship. Okay, one-to-one relationship. Okay, so if it's not one-to-one, then it cannot be what we call that inverse function. So I want to reiterate something here. Wait, let me just adjust my pen size. Okay, inverse function, you must understand inverse expression and inverse function is two different things. Okay, I don't want you guys to get confused with this. Okay, inverse function and inverse expression is two different things. For an example, if you have a quadratic function, okay, let's say I have a quadratic function x, okay, x square and then plus 4x plus, for an example, maybe plus 16. Okay, assume, okay, I think we better put 4. Okay, so assume this is the function. Okay, so this is a quadratic function, and then when they ask you does this function have an inverse or not, we all know for us to find a quadratic function inverse is true, you have to complete the square first. Okay, once you complete the square, then you let y equals to fx, and then you can find your expression for that inverse easily. Okay, so I'll write here expression for inverse. It's two different things, because I always face this problem. The students ask me, I thought they ask you to find the expression, then why you say it doesn't have an inverse? So you see, f inverse x is the expression for inverse. Usually you can find the inverse expression for most of the function, but you want to declare whether that inverse has an what we call the inverse function is two different things. Okay, so don't get confused with this. Maybe I'll share several links of video on the description of the YouTube. You can actually check there on this kind of thing. Why I want to tell this, because in function usually our pattern is they'll give you maybe two or three function. Then on three function, first part A they'll ask you to find f5, what is the answer. Then part B usually they ask you to find inverse or composite, and then the last one they ask you mention whether this has an inverse or not, or what we should do, what we should set the domain for it to have an inverse. So like I said, you can actually get inverse expression, that means f inverse x, the equation you can get easily for any type of equation. But whether that equation has an inverse or not, it's a question mark. So you need to determine whether that function has an inverse or not. That's the most important thing in identification of inverse function. Okay, so maybe I'll show you here. Okay, sorry, I'm drawing on the screen. So you know, quadratic function is, let's say this is a minimum graph. Okay, so let's say if I want to find the what we call that, the inverse, whether this one have an inverse or not, we need to check whether it's a one-to-one relationship. The moment you project a line straight from your x, okay, you see this blue line. Okay, you project x, you notice for one type of y value, all right, this is your y value. For one type of y value, you're going to have two different x. That means many to one function has been declared at here. That means it does not have an inverse function. But like I said, by doing completing the square, you can actually get the inverse expression, but not necessarily it has an inverse function. Okay, so you might want to take note on this. And then this is the first part when you study way earlier. Let me clear the screen. Okay, and then the next part you need to do is you need to focus on use notation. That means what is fx equals sine, f double dot x, what it means. Understand the relationship between y fx. Basically here what they're talking is about between a normal function and also the modulus. Okay, so modulus, you know, modulus, the purpose of modulus is to convert all positive to negative. By right now you're going to sit for IGCSE soon, you need to know, and maybe linear, quadratic, or trigonometry. As I mentioned earlier, a function can be linear like fx equals to 2x plus 3, or it can be quadratic like I expressed just now, or it can be a sine function. And then explain in words why a given function is a function, why it does not have an inverse. Okay, so this one I already declared earlier, why a function does not have inverse, mainly because it's not one-to-one relationship. Okay, they don't have other reasoning. You can Google about it. They have mentioned in Google itself that a function does not have inverse only when they are not one-to-one relationship. Pretty much that's the explanation. And then find the inverse of one-to-one function, form a composite. Composite, you should know, that means they give you fx and gx, and they ask you to find fgx, or perhaps they ask you to find gfx. And then use sketch graph to show relationship between function and inverse. Alright, maybe we can share right here. Okay, what they mean by show the relationship. Okay, this is one line and this is one. Usually we express in dots. Okay, so this will be your object, and then this will be your image. And then I believe you guys still remember we have this thing that we learned long time ago called as your mapping diagram. So when they ask you to use graph to sketch to show the relationship, you can, this one we call as mapping diagram. Okay, so in mapping diagram what we do actually is we just map the value. Okay, let's say this is 1 to 2, and then 2 to 3, 3 to 4, something like that. But when they say use a sketch graph, okay, sketch graph, this is what we mean by sketch graph. You plot a graph, right, and then you can put your, what we call that, your object and image on the axis. You should know by now which axis represent object and image, and then you just maybe put a cross or dot, and then you can join to show the relationship between a function and inverse. Because if it's a function and it's inverse, that means it has an inverse function, it must be a straight line or a graph that possess one-to-one relationship. Like you see, this is a one-to-one relationship. That's what that last line is talking about. Okay, so I think I've covered most of the important thing about function. Okay, now we look into a what we call that the next one, quadratic function. In quadratic function, the most important thing we learn is finding the maximum and minimum value. All right, I want to highlight this. You have learned how to calculate maximum and minimum value a much more easier way, which is through your differentiation integration, whereby your double differential you can prove whether it's a maximum or minimum. But remember, if they ask you to express in completing the square, or they specify a method, then you must use whichever method the question say, and then use maximum and minimum value to sketch the graph. Okay, you should know what is maximum and minimum value to sketch the graph mean by right now. That means, okay, I'll draw the graph here. Okay, so like this is a minimum graph, and this minimum graph has a minimum point. So this point that I put cross there, you need to know how to determine from your equation, and I've taught you that to obtain that you have to perform completing the square, unless the question say you can do differentiation. You have to read the question. We'll cover a few examples later, and then you need to sketch the graph. Determine the range for the given domain. You need to know what is domain by now, and then know the condition fx equals to 0 to have two real root, two equal root, and then no real root. By now you should know what they mean by when they say two real root or two distinct root, and then two equal root, and then no real root. Okay, one more thing I want to cover. Intersect to a given curve, tangent to a given curve, not intersect to a given curve. Okay, so basically this thing is let me just type here. It's a very simple formula that we have learned a long time ago. Okay, it's actually b. The moment I write here, while you're watching the video, you'll notice. Okay, the formula is quite pretty straightforward. B square minus 4ac, and then depending on what is your equation, like for two real root you'll have less than 0, two equal root equals 0, no real root less than or equals to 0. Sorry, the real root is more than 0. Then intersect at a given curve more than 0, tangent to a curve equals to 0, and does not intersect the curve, that means lesser than 0. So this kind of formula, I mean this kind of keyword that you see in the exam, you need to know that you need to use b square minus 4ac. Okay, so these are the basic things you need to know in this chapter. And then the last one is solve what we call a quadratic equation to find real root and find the solution set for the quadratic inequalities. Basically this one we have seen last time, a sample question where they'll give you one equation, y equals to x squared plus kx plus something, and intersect with y equals to something. They'll give you two equations. You even have encountered during your CT1. Okay, they'll give you two equations, and then they'll purposely use this keyword called this equation has a tangent to the curve or does not intersect to the curve, and then or maybe they'll give you equal root or no real root. So the moment you see this, you know you need to use b square minus 4ac, whereby you do simultaneous for that two equation, and then you utilize your b square minus 4ac depending on the keyword. They will specify the keyword clearly to you, either intersect, tangent, does not intersect, or maybe real root, equal root, or not real root. Okay, so we'll go to the next chapter, which is our equation, inequalities, and graph. Basically in this chapter I will just highlight for you the important thing the important thing by now you should know is that how we actually solve modulus function. Okay, equation, inequality, you need to know how we solve modular function. So I'll write here solve graphically or algebraically. Okay, so in algebraically we have learned last time, if let's say you have two sides, left and right side, you have modulus. I taught you two different way. Either one way you can actually get a option for positive and negative from one side, or perhaps you can add a square to both sides that will eliminate the square root. Okay, so I'm gonna highlight here. If they ask you to solve algebraic equation, then you must do to what we call that, either you take option for positive and negative, and then you add square, or otherwise you can draw graphically. Graphically means you are required to draw and then you see for the intersection. And then the next part we learn in modulus is usually that they will ask you to sketch the graph. Okay, they'll ask you to sketch the graph. So I've told you to sketch a graph. Let me highlight here. Okay, these are the things they put in equation, not our problem. Our problem is that how do we sketch the graph. So how do we sketch the graph? I've told you, you sketch the graph by assuming that without the modulus, then later on you add the modulus. That means, let's say maybe I'll just sketch it here so that you can see clearly. Okay, so this is one line. Okay, so I told you last time, you just sketch your graph. Maybe this is your graph, you ignore the modulus part, and then later on you just invert it. Okay, when you invert it, of course you need to get what we call the legend of few points. Then when you invert, that negative y-axis will reverse to your positive y-axis. Okay, so that's one that we learn in the what we call the equation inequalities and graph. And then next part, sketch the graph of a cubic polynomial. Okay, so cubic polynomials and their moduli. Okay, so this one I have told you earlier. All you do is you want to draw this kind of graph, let x or y equals to 0, and then you get your coordinates, must get your coordinates. Just draw the graph assuming the modulus doesn't exist first, then later you reverse the modulus. And then the last one, solving cubic inequalities in the form of this. Okay, graphically you so indices and cert using the denominator is where the keyword. Okay, you have learned this thing we call it the rationalizing denominator conjugate. Okay, you have learned conjugate. Conjugate means what? We want to make sure the denominator doesn't have any square root. Okay, so what do you mean by perform simple operation with indices and cert? So indices, like we learn, if same power you can actually add them up. If they are plus and they are multiplied, then if division we can minus the power, and we combine a power in a bracket. How do we express fraction power to a cert form, and then how do we express a power -1 to 1 over. Okay, but I think the most important thing is cert. Okay, cert is something very important. Cert, you cannot use calculator. Okay, if there's a problem solving involving cert, you are not allowed to use calculator to directly show the answer. So if you do this way, your marks will be penalized. That means instead of getting 5 marks, you might only get about 1 mark, or maybe they might not even give any mark at all, because you directly press in calculator and show the simplified version. Okay, so take note about conjugate. This is something I want to highlight. Conjugate means we want to make the denominator does not have a square root. About factors and polynomial. So in factors and polynomial, we have few theorems here. Use the remainder theorem and factor theorem, find factor of polynomials, and solve cubic equation. What do they actually mean, use the remainder theorem? The moment when you see they say x is let's say x is a factor of something. Okay, I've told you x is a factor of something means it can be divided with a remainder of 0. Okay, so I'll write here it can be divided with a remainder of 0, or when they say the remainder of 0, also that's a one keyword. Okay, so remember, x is a factor of something, that means the remainder is 0. So you can basically substitute that particular question as f. Let's say they say the factor is 3, you can write f3 equals to 0, and then you solve this. Usually if this kind of question comes in your exam, they'll be in a way that they'll give you unknowns. Okay, maybe I share some sample question here. You'll see a bracket fx equals to, maybe they'll give you x, okay, I'll just write here, okay, x power 3, and then follow up by x power 3, and then they will give you maybe ax plus bx and then plus 4. And then they'll give you some keyword. They say that they'll say x equals to 3 is a factor for the equation something, and then they will tell you another one. They'll give you another one, maybe x equals to 4 is a factor with remainder of 2. So how do we actually write this information to a way that we understand? We write actually f3, okay, f3, because remainder is 0. The moment they say it's a factor, you must understand by now that means remainder is 0. Okay, they won't mention to you remainder is 0. They'll just say factor. If factor means remainder is 0, if it has a remainder, they'll specify like that. So that one, the next statement will be f4 equals to 2. And then what you do, you just take this equation, f3, you sub inside, equate them to 0, and another one 2, then you solve simultaneous, you'll be able to solve the question. The next one, find the factors of polynomial. I have told you factors of polynomial, usually what we do is we see if they give you a factor, then you perform long division to find the other factor, or otherwise you can use trial and error method. Trial and error method, it's a bit tedious, but it's possible. You can choose few values like I told you last time. You can start from -3, -2, -1, 0, 1, 2, 3. The moment you put this kind of value, you must make sure that you are getting a 0. When you get a 0 only, it's a factor. If it's not a factor, that means you will get a remainder. Okay, so take note of this. And the last one, solve cubic equation. What I mean by cubic equation, that means after you factorize, you'll get x minus 3, and then maybe x plus 4, and then the last one they will give you cubic, means you must have 3 bracket x minus 7. So what they mean by solve, that means you need to tell okay, so for this you know x equals to 3, and then followed by x equals to minus 4, and then the next one you'll know x equals to positive 7. Something like this you need to know. Okay, so in this chapter I believe we have done a lot of practice. Okay, so you can take this opportunity to know what are the important things in this chapter. In this equation, I believe I don't have to explain this. Okay, you have two major methods that you have learned at maths. Okay, but we all know deep down there elimination rarely we use, but 90% of the time we use substitution. Substitution is more effective because of the questions difficulty that we have. We have power 2, power 3. If you want to do elimination, I won't say it's impossible. You can do, but you need to think a lot. But substitution is something that you don't have to think a lot. When the moment you see, you directly can do it without any hassle. Okay, so in simultaneous equation, I would highlight I'll give you most attention to the substitution method, because that's the question that we deal most of the time, regardless of whatever chapter that we're doing, all the way to integration and differentiation, logarithmic and exponential function. So in logarithmic and exponential function, the important thing you need to do is the simple properties and graph. Okay, that means how a log graph look like, how an exponential graph look like. That means the log and the exponential series, and then graph of this. Okay, graph of this, basically they'll give you some weird equation, y equals to maybe x cubed plus something. So they'll ask you to linearize this kind of equation. Okay, these are the things you need to know. And then you need to know and use the law of logarithmic. So law of logarithmic, I believe we all are good in that. Okay, basically when you have two log, but you must know when you want to combine a log, you must make sure the base is not same. Okay, when the base is not same, you cannot combine. So of course base not same, that doesn't mean the end of the world. We have learned that if the base is not same, what do you do actually? You can actually change the base. Okay, so you can actually change the base if the base, let me just scribble here, if the base is not the same. So you are not allowed to combine, you are not allowed to combine if the base is not the same. So you need to make the base same. I've taught you last time, we got two way. One is the blank check method. Remember I said you split the unknown, the upper power, the upper value and the base. You split and then you can fill whatever base you want. One is the blank check. Another one is you reverse the base and the number, and then you put 1 over. It's up to you whichever way you want to use, but I prefer blank check, because blank check is much easier for you to control your equation. Okay, it's totally up to you. I'm not forcing you, but I'm just highlighting to you the important keyword in this chapter. Then last one, solve equation. So solve this equation, we have learned last time. Okay, to solve indices equation, usually involving one extra step where you need to what we call that, use the let y equals to something and then use substitution method. So solve this equation, you must pay attention. Maybe you want to take note or go and study a bit. We have this substitution method. Okay, substitution method means they'll give you a very weird equation, x cubed, maybe they'll give you e power 2x 2 plus something. So you can actually see one quadratic function pattern there. So you need to use substitution. That means let y equals to that sophisticated function there. Okay, maybe e power 2x, you declare this, and then you can actually solve it so and forth. Okay, so why I want to highlight this, because it has a high chances for this kind of question to come out during your exam. Okay, we have seen the past. So like I say, logarithm and exponential is quite important, because why, you will see it in your differentiation and your integration as well. And then moving on, straight line graph, y equals to mx plus c. This one ties a lot with our indices and log, because why, like I said, you see they say transform given relationship including y ax and y abx. You already learned that a straight line equation must be what we call that is y equals to mx plus c. That means the highest power a straight line equation can have is 1. But you look at what I highlighted there, including y equals to axn. You see I highlight in purple color now. So that means, you know, when you have power to the equation, it cannot be a straight line, but somehow we need to convert it to straight line. So these are the part when we have to challenge ourselves and include what we call that log law. Okay, so this is the part you will use log and what we call the log and natural x, the same thing, log or indices. Okay, most of the time we use log rules to transform the equation to linear form. So if you don't transfer, actually then you fail to answer the question, because usually the question asks you find some terms, so and forth. So to find those terms, you need to actually convert it to y equals to what we call that mx plus c. Okay, you can see, allow me to just get my highlighter. You see the syllabus content you mentioned has determined unknown constant by calculating the gradient or the intercept. They say intercept, but we know in straight line we only have one intercept, which is your c value y intercept. Okay, so that's why I say you must use log and indices rules to actually transform that equation, that non-linear equation, to a linear equation, so that you can find few things. And then next one, solve question involving midpoint and length of line. Okay, so midpoint also I want to add another thing. Oh, there, here we cover already. Okay, midpoint, you know actually what is midpoint, and length of line I don't need to talk about a lot. Length of line, you guys know, we use Pythagoras theory. And then parallel or perpendicular. Perpendicular, actually we all learned the keyword that I taught you last time, M2. Okay, so you need to find your M2, and then including finding the equation of perpendicular bisector. I told you the perpendicular bisector means you need to find two things here. I'm just going to write here one time, okay, so that you know. For perpendicular bisector, you must find two things. One thing is your midpoint, and also your M2 gradient. Sorry that I use this word, because we have learned the M1 times M2 equals to -1. So M2 gradient, actually we're looking for the other gradient. Okay, so remember when we say perpendicular bisector, you must find the midpoint and also M2 gradient. It's a good time for you to recall all of this keyword that I highlighted. Okay, and then I think pretty much that's all in this chapter. Okay, so midpoint, length of line, parallel, perpendicular, and then converting a non-linear equation to linear by utilizing the log and indices rule, and finding the unknown using the gradient and the y-intercept. So on arc length, and then sector of area of circle. Actually nothing much here. And then use radian measure. I can write here down if you want also. Okay, we only have two formula by right. Okay, S equals to sorry, I can't draw that symbol here, r theta, and another one you have area of a sector is actually 1 over 2 r times r, and then you multiply with theta. So these are the two formula only you learn in circular measure, but of course sometimes we have elements like Casotua and several things. But in this chapter overall we only learn S equals to r theta and 1 over 2 r square theta. And then next one you need to know is how do we convert radian to degree, and then degree to radian. Okay, I also have explained to you the way is actually, if you want to convert degree to radian, means you need to take the angle in degree divided by degree, so that you cancel off the unit times pi. So let's say you have radian, you want to convert to degree, then you do what? You take the radian divided by pi and times 180. Okay, but of course always follow the questions. Okay, you must follow the question and see the domain set by the question. Okay, sometimes the domain set by a question, okay, the domain set by the question are often in radian. Okay, so if they want in radian, that means you might actually prefer to do your calculation in degree. After you do, you realize, oh my god, it's in the question asking radian, then the mark will be deducted accordingly. Okay, so you want to take note on this kind of certain things. Okay, make sure that you always do your calculation in what we call it in follow what the question asks. Okay, pattern will ask you to prove, solve the equation, and then find the values. Okay, we all know that. So you see, they will tell you got what is sine, cosine, tangent, and then secant, and then cosecant, and also cotangent. Okay, so we all know secant means 1 over cos, 1 over sine, and then 1 over tangent, so and forth for each of the respective thing. And then understand amplitude and periodicity. Okay, periodicity means period, but I have taught you that we have learned something called cycle. So you need to know the relationship, how a cycle merge with your period, and then amplitude determine the height of the cosine or sine graph. Then this one, especially the sine x and sine 2x. So this is what I'm telling you. Okay, sine x means one complete cycle 360 degree, because we have one x there, and then sine 2x means you have double cycle there. That means double cycle means in 360 you can fit 2 cycle. So what is actually period is about? Period means where your first cycle end. For sine x, your first cycle ends at 360, whereas for sine 2x, your first cycle ends at 180 as your cycle increase. And then the next one, they ask you draw and use the graph. So drawing all this graph, you should be pro by now. Okay, you need to know why we plus C, plus or minus, we actually adjust the amplitude of the graph. And then what else we have? Where A is a positive integer, B is a simple fraction, integer, fraction we have. So that means this one, what they're telling you, that maybe A, you will have a fraction. So fraction means, you know, your size of your graph, your frequency of your graph going to reduce furthermore. And then next one, use the relationship. So we all know why usually we use this relationship. Mainly is because for two reasons. One is because for proving, and another one is because we want to solve the equation. Okay, so again, I'm going to highlight here, okay, to do proofs, maybe I'll just add, okay. So two reasons we use proving. Another one is for what we call the solving. So for solving, like just now indices I mentioned it, you are required to use substitution method. Okay, you have to use substitution method. If you don't use substitution method, you can't solve. Like sometimes you might have tangent 2x squared plus tangent x, but you can see some pattern there. It's a quadratic equation. So what we do usually, we will let that particular variable equals to let the x equals to tangent x. The reason we do this because we want to ease our calculation, then later we find what the tangent represent. Okay, and then another one important thing in trigonometry you need to know is our golden rule, which is our ASTC. Okay, so I'm just gonna write here, add sugar to coffee, or you can actually follow what all student trust Cambridge something. Okay, add sugar to coffee, or all student trust Cambridge. And then also you need to know how we calculate our angle here, 180 minus theta. And then this part here you'll have 180 plus what we call it theta. And then iso share here for this quadrant will be 360 minus theta, and then you need to know which quadrant are positive and which quadrant are negative. So quadrant is very important in solving, and also when you want to do question involving differentiation, integration, and circular measure as well. Solve simple trigonometry equation involving 6 trigonometry function like I mentioned. Some of the equation you can't solve easily. You need to use this sine squares cos square equals to 1, or maybe one of the identity you need to use to solve it. Then prove simple trigonometry identity. Okay, proving simple trigonometry identity means you need to show how the left become right or the right become left. Okay, so these are the basic thing in trigonometry you need to know. But I can generalize for you. Our usual pattern, they'll ask you sketch one graph and then solve the equation, and then maybe they'll ask you find the value. Then when finding the value, you need to check lah. Remember I told you the negative means to indicate, give us the indicator to determine which quadrant we are actually looking at. Alright, so that's pretty much about our trigonometry chapter. And then next one we have permutation and combination. So in permutation and combination we have keywords that I've taught you during class time. Okay, so you need to know permutation case. How do you actually distinguish between the difference between a permutation and combination, and then know how to use the n notation, which is the n factorial, and the expression for permutation and combination. For combination we have a formula, and for permutation we have formula. Take n and r at a time. Answer simple problems on arrangement and selection. So I've told you before, and I'm gonna maybe reiterate back here how we actually tie things up. Alright, so for arrangement usually we use permutation with NPR, and for selection usually we use combination. Okay, but it's not a general one, but you can use this as a golden rule. Then you need to consider cases with repetition of object with object arranged in circle involving both permutation and combination. That means sometimes you might have two together. We have done a lot of example during class, so I don't think you have problem. You have problem also, you can take the opportunity now to actually reflect back and study back. Okay, so I'm just going to highlight here NPR and NCR, and then we have learned last time that you take let's say we have 15 people. Once you select the people, the total number keep getting lesser and lesser. So these are the things that they say cases with the repeated object. Okay, like this, repetition of object. And also what if you don't have a repetition object? That means the object get lesser and lesser. So basically NPR and NCR. And then the next part we learn about series. So in series you need to know the binomial theorem. Okay, how we actually come up the binomial theorem, I've told you a way. whereby we actually learn remember the pyramid. So in the pyramid, I also taught you a shortcut where you start from x0 all the way to whatever your expression value is, xn, and then from the other side you go here, and make sure you remember all constants, that means all binomial term will have what we call the NCR there. Okay, so you need to add your combination, the NPR or NCR there. Okay, make sure you check. And then here they got mentioned. Okay, so they already mentioned use the general term n and r. That means you need to use this formula. This is what I mentioned. Okay, because usually how the series will come in your exam, they'll specify to you, they give you an expression, maybe 2x cubed plus x, and they'll put in bracket power 8, then ask you write down the first 3 terms. You don't tell me you're going to expand 8 times the bracket. That is why we learn binomial, whereby we can use this formula, the general term, and then we can make sure we use the NCR, put the NCR in front and whatever that value is, and then the terms A and B value that, like I highlighted. Okay, so you might want to take note on this and go and study. This is usual pattern you'll see. Then recognize aromatic and geometric progression. Okay, this is new in your syllabus, so you might not able to find any example in past year. Aromatic and geometric is newly introduced this year in this chapter. Previously it was standalone, so you have to see some example from the past. Use formula for n term. Okay, that means aromatic, to find the n term for aromatic and the sum for aromatic is totally different, and also to find geometry it will be totally different. So I'm going to highlight this. And the last one, use the condition for convergence of geometric progression, and the formula to find sum of infinity of convergence. Sum of infinity means basically what? The S infinity equals to 1 over A minus R. Something, I'm not sure, I can't remember the formula, but I think roughly around that. Okay, so you might want to check note on that. Okay, sum of infinity, and then the n term, the sum of aromatic and geometry. Okay, you have to check on that formula as well. And then I think that's okay. So usual pattern for series means they'll give you a binomial. We have noticed this. They'll give you in part A one big large binomial expression. They'll give you in power 8 or power 9. Then you have to find the first 3 term, and then the second part they will add you the same expression they'll give there, but they'll say multiplying with another simpler equation. Perhaps it might be a linear equation or it might be a quadratic equation. Then they'll ask you find the coefficient of x power 4 specifically. I've told you before, even in Zoom class and a lot of time when we do tutorial, I've told you usually the part A answer will be utilized back in the part B. So you can actually utilize take advantage of the part A and ask yourself which times which you'll get x power 4, something like that. Okay, if you do pass, you'll notice what I'm saying. Okay, even in class also we have done a lot of this kind of tutorial, so I'll just go through with you the important thing. The next one is vector. So vector, we have learned a lot in vector. Okay, so I will just highlight for you the things that is covered here. Okay, use vector in this notation. Like I said, we got 2 notation. One is the IJ form and one is the column vector A, B. It depends. If they ask you to express, you can express, but we know usually the best way in maths we solve vector is through IJ form. And then you need to know how to use position vector. Position vector always respect to, I mean, usually A will be your position vector, but it depends on the situation. And then unit vector, you need to know how to compute your unit vector through Pythagoras. Finding the magnitude of a vector, adding a vector and subtracting a vector is not a problem. Multiply vectors by scalar, and then compose and resolve velocities. Okay, so compose and resolve velocity, I think this is one part that we have a lot of students struggle a lot. Okay, there's few steps you can do to resolve the velocity, so I think this is something that you guys want to take note on that. Okay, so important thing in vector, you notice they'll give you a big diagram. Then the first part, this is one thing they didn't cover here, finding unknowns. Okay, because we have encountered that. So finding unknown is in your syllabus, that they'll give you something, expression equals to lambda, another expression equals to mu, and then they'll ask you to express in terms of lambda, express in terms of mu. Then the last part, they'll ask you find the lambda and mu value. This is one thing that you will see. Or maybe they'll just go very basic, ask you find what is CD vector, B vector, or something with giving you some ratio. Okay, so these are the most common thing that you will see in vector but don't forget how you want to find the unit vector and also the magnitude as well, and what's the relationship of a magnitude. Next one, okay, so this chapter actually they compromise everything into one: differentiation and integration. Differentiation, integration, basically differentiation, we got four methods, as I've told you before, even in class as well. Okay, I'll just explain to you quickly here. Let me just arrange my size. So differentiation, you have total 4 method. One is the chain rule, and then product rule, and then quotient rule, and then the last one you learn your usual differentiation. I just said differentiation here, okay? So you have actually total 4 methods to do differentiation. I'll do the contrast here. Integration you have no lot of method, only one we learn is through integration by part, okay? So that one it's a higher level, but I think we have Miss Catherine already covered with you in the class. So why I write side by here, you actually know the reverse of differentiation is actually integration. They both are tie each other, okay? So usually why we integrate, as you learn, okay, I'll just explain here. In integrate we have a extra what we call that extra branch, whereby using integration we can do some other problem. For an example, problem involving what we call that kinematics, okay? So kinematics we can actually utilize integration and differentiation as well. Remember I told you the formula S, V, and then A, okay? That means if you go down you gotta differentiate. If you want to go up you need to find the integration, okay? That's one. And then they explain here, understand the idea of a derived function. So derived function means the difference between a derivative and integral. You need to know that. And then next one, use the notation. So you need to familiarize like this. F1 apostrophe means one differentiation. F double means 2 times you differentiate. Then you know what is d2y dy or dx. So d2y we have learned last time. All right, I'm gonna just point an arrow out here. Sorry, it's too big. Okay, so we have learned that why the reason we learn d2 dy is only to serve for one purpose. Each we want to find the maximum and minimum value only, okay? So actually we do all of this, we want to find a maximum minimum value. The second differential doesn't give you any sort of benefit. Meanwhile we already learned that our dy dx actually give you something extra, which is representing your gradient, okay? So you need to know this. Double differential only tell you whether that expression is or that particular point is a maximum or minimum, whereas dy dx is the gradient of that function or at that particular point, okay? Same thing with f double prime and fx. Allow me to clear the screen. And then for the next part, let's go through. They say use a derivative for standard function. I think I already explained this earlier. So you need to know how you differentiate sine, cosine, tangent, exponential, ln, okay, together constant multiples. And I've told you last time, if you have a function, when you have something they ask you differentiate, and if it's in a fraction, I told you to make it single line. If you don't make single line, whether you want to integrate or differentiate will be hard, okay? That means for an example, you have an expression 3 over x cubed. So I told you, you do what? You bring the x cube on top. That means 3x power negative 3. Then you perform your differentiation or your integration. Otherwise, you'll make a mistake over there. And then they say differentiate product and quotient function, like I covered earlier. Apply differentiation to gradients, tangents, and normal, okay? Tangent in normal is actually your M2 gradient. That's what they're saying, okay? Stationary point, I've told you, at the point of stationary point, what happened is actually your dy dx equals to 0, okay? So usually in your exam, if you see the moment they mention stationary point, you must declare that your dy dx is 0. If you don't declare that, then it'll be very hard for you to solve the problem. The next one is rate of change, okay? Rate of change is basically delta y or delta x, that chapter. The one. And then small increment is actually approximation, where we'll find the changes. And then practical maxima and minimum problem. This one is involving double differential. Then they say use your first and second derivative to discriminate between maximum and minimum. Remember I told you we do double differentiation to test whether that point or function is a maximum or minimum. Then understand integration as a reverse process of differentiation. Allow me to use another highlighter so that we can actually see the importance of this process. I already mentioned to you up there earlier. Differentiation is actually, or integration is actually reverse process of each other. Then you need to know how you actually integrate this thing. You either add ln or you bring on top. Integrate function like this, okay? In differentiation also we call that chain rule, sine, cosine. Then evaluate definite integral. Apply integral to plane area. So I want to highlight this. How do we actually find area? By involving you until you go and find the points, so and forth. Maybe I'll just share with you an example here, okay? So let's say we have this graph, okay? Sorry, it's too big. I adjust my pen size first, okay? So let's say we have this graph here, okay? So wait, I get a pen to draw. So you have a graph here, okay, this is the graph, and then they ask you to find the area subtended or bounded by the curve, and then they'll tell you make sure that find the area in between these two, okay, ignore that light side. So if you want to find that means first you need to know what is this coordinate here. Only then you can find the area, okay. You won't see simple area, you'll see something like this, okay. So if you want to find the area that is subtended between the line and the curve, you need to get the bigger area minus below the curve. Only then you get that upper area, okay. In class I've taught you, we call that the Doraemon pocket, okay. So that area labeled as A, that's how you find, okay. So these are the things you need to know in integration. So take note, differentiation usually we use to actually get the gradient and to find whether that point is a maximum minimum. But integration, the main application of integration for this chapter is actually to find the area, and also we can use in like I said, you can actually use differentiation. Remember SVA, you go down in differentiate, go up integrate. Kinematics problem involving displacement, velocity, acceleration, okay. So this one you have to actually do a lot of revision. Like I said, when you integrate, usually the problem when you integrate, you must remember you must add the plus C there. If you don't add plus C, then your answer is wrong. But by right, when you find area, you don't write your plus C, and I think I've explained many times, okay. When we find area, we need to integrate. We don't put plus C because why? Here you'll have one C, here you'll have one C, both C cancel off. So there's no need for you to put C. But then when you integrate from acceleration go to velocity, from velocity go to displacement, you need to add C because it will change the entire equation, okay. So when we add C, we have few ways we can do. Like I say, we declare at displacement 0, velocity is 0. Those examples you need to know. Okay, so pretty much I have covered the important things, important keyword that you need to know in each chapter. Okay, the slides I will the link to access to this slide I'll put in the description, the YouTube video. Maybe you can watch and also go through the slides. Okay, the next one, they say command word. Okay, why I want to highlight this is because I'm not going to highlight, maybe you can just see. Okay, there are later we'll cover one important part of our seminar for this video. Okay, so let me just go through. When they say calculate, work out from the given facts, figure and information. Okay, this is the thing, generally using calculator. That means when they say calculate, actually if you don't show the working, you use calculator, you'll get full mark. Normally this kind of situation you'll see in your maths. Okay, they'll give you one function, want to test you whether you know how to use calculator good or not and get that particular answer. So take note on that, calculator means generally using calculator. There's no working you need to do. Next one, describe means state the point of the topic, characteristic or main feature. So describe usually you'll see in differentiation or integration or maybe in kinematics, okay. So you need to precise to the point. Don't talk a lot like an essay, just straight to the point and move on. Determine, establish certainty. Okay, determine means you must be with evidence. That means they ask you determine whether that point is a maximum, minimum, means you must provide the evidence. Don't just simply write, I feel this is a maximum, this is a minimum. It doesn't work that way. Remember, see the keyword I highlighted. They say establish with certainty. That means evidence must be provided. Let's say I give you an expression with a point and ask you determine whether this is a maximum, minimum point. You must do first differential and then do second differential, then you sub the value and you see. If you get positive, it's a minimum, you get negative and maximum. So you provide the evidence. Then next one, explain means you must explain in clearly, okay. That means a relationship between what they ask and what they're expecting, okay. Explain. So set a purpose, a reason, make a relationship. See, evidence is very important. Why and how it support the relevant evidence. Okay, I think this one usually we don't see in maths, but you still need to know this keyword. If it's here, then you will see, but in a very rare occasion. Give, produce an answer from a source. Okay, give your answer. Okay, this one basically you will see in what kind of situation. Usually you see give, that means they say give your answer in 2 significant place digit. Give your answer in radian. And then give your answer in something blah blah blah. For maths usually will face when they ask you angle, give in radian, and then give in 3 significant figures, something like that. Okay, so that's about it. Then plot means mark point on a graph. Okay, plot means mark point on the graph, and you of course you need to draw the graph. Then show, that means you need to prove. Okay, show we all know already what we're talking about. Show usually we see in trigonometry. That means you must show the left side equals to the right side or vice versa, whichever that you make a choice. Sketch. Okay, sketch is usually in your syllabus, and it's usually come under inequalities, the chapter 3 that I mentioned earlier. Okay, so they'll give you some modulus function and then they'll ask you to sketch. Sketch means you don't need to go what we call that very detailed. You see, freehand drawing. Okay, so you can do freehand, you'll get full mark. Don't take your ruler, go and draw nicely, no need. Okay, you're gonna waste a lot of time there. Okay, so make simple freehand drawing, you get your full mark. If you see the word sketch. State means express in clear term. Verify, you need to show evidence, or maybe check evidence whether it's true or false. Then work out, calculate from given figure fact with or without the use of calculator. So this one usually the question is specify, and usually you see this kind of workout in set form. Okay, they'll give you some set expression there, then I'll tell you workout. So you need to work out. Workout means you must show the evidence. If they say without calculator, you must show each step. We will cover this later in the examiner's report. Then write, give your answer in a specific form. That means write in two significant figure. Write in radian. Oh, that's what they're telling. Then write down means give an answer without a significant working. That means you don't need to show the step. So these are the important keywords you need to know. But actually, the most important thing for me is sketch. Sketch you will definitely see, especially inequalities. Okay, so sketch, just draw freehand, but make sure you label everything properly, your y-axis, your x-axis, and just sketch. And then another one thing is show. We all have experienced a lot in trigonometry. Explain means you need to explain. Explain usually you'll see in function. They'll ask you explain why this function doesn't have an inverse even though it has an expression. So how do we explain this? You say because that expression doesn't have one-to-one relationship, therefore it does not have an inverse function. Okay, and then plot, so and for. Okay, so I think that's all for the keyword. Okay, this is the most important one, marks and grading. So you have total 2 paper. Okay, 2 paper, 2 hours 80 mark, 2 hours 80 mark. Okay, I'm going to share something, a tips for you. Okay, you can consider to do this, is up to you, I'm not forcing you. Okay, so this is the tips actually Miss Catherine has taught me. What she say actually. Okay, you see you have 2 hours. Okay, 2 hours is equivalent to 120 minutes. Okay, 120 minutes, and your paper is 80 mark. So Miss Catherine last time told me, you tell yourself 1 mark equals to 1 minute. Okay, why I tell this later, I'll cover for you. So you can set this goal that 1 marks 1 minute. That means in your paper, let's say you see a 3 mark question, you set 3 minutes. Set or see, always constantly see or watch. Okay, 3 minutes. Why I tell this? Because our purpose when we do at best paper, we want to secure our marks as much as we can. So you see, we have 2 hours, we have 120 minutes. So your total paper is 80 marks. Okay, 80 marks, and then you'll have a total of 80 minutes. So by right, you have additional of several minutes left. Okay, so 120 minus 80, you got 20, you got 60 minutes. Actually, you have 40 minutes extra. So why I advise you to do this, so that you will make sure you don't waste too long in one question. Okay, so if you waste too long in one question, the next question for you to solve will be the time will be shorter, and then you get panic. So this is the golden rule that Miss Catherine taught me. 1 mark 1 minute. So you can set the standard when you do your paper. Okay, different paper people have different way. I'm just sharing with you. Okay, so candidate to answer all questions. Paper consists of various length, calculator require. Actually, paper 1 and paper 2 don't have much difference. Okay, they are the same thing, just that they differentiate in 2. One is 80 mark, one is 2 hour, one is 2 hour, maybe, so that they don't want you to get exhausted of the long hour. Okay, so each paper formula will be provided, everything will be provided in the paper. If you need a space to do working, graph, all will be provided. Okay, so remember this golden rule that I told you, 120 minutes, 1 mark equals to 1 minute, 80 marks equals to 80 minutes. Notice in the next slide. Okay, in the next slide I have put here. Okay, so you see 2 hour, this is what they're telling you. Okay, so all candidates must take paper 1 and paper 2, each paper 80 marks, so total 160 mark, they divide, and then you see candidate are eligible for A star to E. F and G will not be available. Candidate who do not achieve the minimum mark, grade E will be unclassified. That means if you fail, you get F or G, it will be unclassified. So you must score between A to E for additional mathematics. Take note. Okay, so if you get lower than E, it won't be on your paper. They'll put unclassified. So to get A star, you must make sure you get 144 marks out of 160. What I mean, paper 1 you can only lose 10 mark. You notice, no? You see, they say minimum raw mark required for the grade A, you must get 60, and your paper 2 you must get 62. So like, remember just now I told you the benchmark for you to set 1 mark equals to 1 minute. So when you set 1 mark to 1 minute, you know you're actually working towards securing your mark. When you do ATMAS paper, you must first focus on securing your mark. Don't rush or show your ego there that I cannot do this question, I'm going to spend time. When you spend time, you might spend too long, 50 minutes, and then by the time you go for other question, you realize, oh, I could do that question and I wasted. It'll be too late. So when you set this kind of goal, every mark I associate with the time, then you won't go wrong. You see, okay, 5 minutes, okay, 5 minutes, leave it. Because not like I want to ask you give up on the question. Leave it, do others, because you still remember you have 40 minutes extra, so you can use that 40 minutes to come back and revisit the question they haven't done and secure your mark. So I advise you, when you do ATMAS, first objective, you should focus on securing your mark. Like I said, you know where you stand, whether you want to get B, C, D, or E. You set your target and then you should know. In this table, is a good table. To A star, you must get 144 mark. That means each of the paper you must get on an average of 70 mark and 74 mark. So that means paper 1 you can only lose 10 mark, and then paper 2 you can only use 6 mark. So if you lose anything lesser than this, you know already, you lost your A star, you fall to the next category A. So take note on this, you can only lose 10 mark for paper 1 and then 6 mark for paper 2 for A star, and as you progress it will move on. This is the important thing you need to know.